Atharva, unmute yourself.
Yeah, good morning, ma'am. Sir, can we start?
Hi, am I audible?
Sir, actually, you are not visible. Yeah, okay, great. Good morning, everyone. I, Atharva Kothawade, on behalf of Shah and Anchor Kutch Engineering College, Mumbai, welcomes you all in a hybrid webinar series 2.0, Innovative and Emerging Technology in the Field of Research. This series is hosted by SAKEC Research Cell. Let's begin this webinar by seeking a divine blessing from Ma Saraswati. It is my pleasure. It is my pleasure to introduce the speaker for this session, Mr. Kulin Patel. Mr. Kulin Patel is a lecturer and industry expert at Bajpa University Academic Center, RAK, UAE. And also he is an artificial intelligence engineer in Doctron Click based in Singapore. He has obtained his Bachelor's of Engineering degree from Vishwakarma Government Engineering College. Along with this, he also mentors many students on various projects. His work on real-time writing with fingers on webcam screen was widely appreciated by LinkedIn professionals. The demo video has been watched by more than 1.2 million people. Currently, he is working on research on tongue image analysis with deep learning model. We would like to honor our guest with a sapling as a token of gratitude from Sakek Research Cell. Sir, please accept it.
Thank you, Atharva.
I am very sure this 2-hour session will be the best technical session for all of us. Before handing over the session to our speaker, I have a few announcements for our audience. All participants, if you have any query in between sessions, please write them in chat box. Frequently asked questions will be taken at the end of the session, and also at the end, feedback link will be provided in the chat box. Participants will receive the e-certificate based on the information provided in the feedback form. Hence, please mention your name and email ID correctly in the feedback form. You must also take a selfie and upload that on a feedback form. And also we have two surprise announcements for you all who are seeking internships and projects. So please stay tuned with us. Now I'll request our honorable speaker, Mr. Kulin Patel, to please take over and start the session. Thank you, sir.
Thank you, Athara, and thank you, SAKEC, for inviting me. So let me share my screen so we can start session. I believe that most of the students are from the computer science background or have the basic knowledge of computing. And let me share first. Is my screen visible to all? Hello.
Yes, yes, sir, it is.
Yes. So this session I have divided in the two parts. First of all, we will look for the applications of the computer visions, and most of the time we'll see that, and then we will have some type of application, or we will have the classification part. If the time permits, we can go longer. So this is my profile on LinkedIn. Just edit if you want to. And first, let me show you my work. This video I had made and with the help of hand tracking tool, and then I tried to write something and made a demo video. सो जैसे मैंने बताया, अपना ये दिस सेशन है ये कंप्यूटर विजन के मीनिंग एप्लीकेशन पे. देन वी विल वर्क ऑन द कंप्यूटर विजन पार्ट एंड वी विल हैव द classification exercise. So I'll start from the how this machine learning and the computer vision started. And before that, I would like to say that this in this era we are seeing the machine learning and data science boom. But if you find, some people find it very difficult, but if you want to enjoy with the computer vision and images, then this is the field you would like to explore. So for the first I'll intro for the computer vision part. What we do is mimic the nature. So first we billions years ago we have developed our eye, because the creatures were developing and evolving in the part of nature. So first we developed and we started watching the things, but at that time we were not able to classify the things. But eventually we evolved, and then we try to analyze, and we have developed the most satisfactory thing that even from the we can identify from the another creatures. So this is we will mimic in the computer vision. So what we do right now is that, like, we have the eye that captures the light, and then it transmits with the help of receptor. So to the back of the mind, there is a part of called visual cortex that processes these images. So if you mimic this, how can we do this? So first we will start with the camera. We have developed the cameras, photographic camera. So this act as our eye part. The photo, then first were the photogenic camera, and then I'm not going into detail because of the time constraint. After the lecture, I'll provide the PPTs. You go through it. Then we get then the digital age of the camera. Uh, then in the digital age of the camera, what is the digital age? So the images are the in form of the pixel, and first for the photogenic camera, there was when the light comes to the photographic film, that it changes the color, and we develop that film. But in a digital, we captures the images and store it in a way of pixel values. And now the part comes from the computer vision. We analyze these values in the form of a pixel. So let's say we have in computer vision some task, we want to identify the objects, let's say dog and bicycle or the truck. So we now in last 4 or 5 years we have developed a very uh, dramatically in computer vision thing. So you see in a real life example that even our phone has uh, facial unlock. We have witnessed this in the last 5 years because we have developed a processing power and better algorithm, so we can do it now. Uh, we have started using in a real daily life. So what is the computer vision is the field of SIC that develop the technique to see and understand the content of the digital image, photographs, and also we can introduce into the videos. Videos is basically what the frames of pictures in we can count in a FPS, frame per second. So we have started using this in a real life or daily life. So first example is like facial unlock, and new application has emerged out of this processing power and new algorithms. Um, so this is the example of a traffic control, or we can say a self-driving car that analyze the objects in a road. So I'll discuss the applications of computer vision in a different field, starting with healthcare sector. How healthcare sector. Um I'm working at a doctor on click. So where I work, I have given a task of tongue classification for the traditional Chinese medicine. What we have in India, Ayurvedic and the other system that we check our nadi and the pulse, and based on pulse our some Ved and some gives the analysis. So in China, they have 5 system. They use nadis and other another systems, and one of them is tongue. So what my work is, I'm doing like a classification of tongue from the point of view of the doctor. So first I started doing segmenting the tongue, capture find the tongue in the image, and then try to classifying it. I have made the model, but I would not be able to show it here because of the scope and the time constraint. But in the healthcare sector we do this. In the cancer detection, there is lots of data for data. uh, Due to data generation, we this helped in our artificial intelligence in such a way that we can classify the cancer, detect the cancer sometimes even better than the doctor itself. How this happens? So we analyze the data, or cancer tumor or the breast tumor or the another tumor, whatever the tumor is. We identify the images and the cross analysis set, and based on the image analysis and computer vision, we can even the cell classification, disease identification, COVID mask detection. These are the applications in the health sector. I'm saying it because I am providing you the broad length of the computer vision, so you can do your project in wide field uh, and not have the small perspective. I am broadening your perspective for the machine learning and the and specific to the computer vision. I'm not talking about audio analysis that we use Alexa and the Google, okay Google, but for the image and video part. Then even you see the news sometimes that robotic surgery had happened in a remote area. So how does it happens? They use only sometimes or mostly we now use the camera only, but in a future robotic surgery we will be analyzing the images and the patients with the help of the artificial intelligence. And even for the students, we don't need like a real patient. We can do this with the help of augmented reality. So they can go there and see a patient in a virtual world. So all this comes under the computer vision. So, and one more thing I would like to mention, that preventive healthcare is the future of healthcare. Let's say uh, we have the X-ray of the patient or to be patient. So we analyze the picture based on our past data, past data that this patient might have will have in the future, or 10 years. This will face of the spinal problems. So we can start acting now and prevent that healthcare, because we can now find the weak part of in the spine. So these all comes under the research part. This field is evolving, and most of the work is in a research. So this was the healthcare sector and applications. Now we will see the in the sports how this happens in the sports. So now we are able to identify the body and parts of it, so we can analyze the body posture of the player, and we can suggest the improvement in the pose estimation and athlete performance as assessment. Let's say take example of football. So if we identify the football player, how it moves, if you want to train some local player, so what we will see that we'll see the video of the Messi or the Ronaldo, and we will input in our computer vision model, and then it will give us some insights that what are the expertise. Even the football clubs using this analytics to predict and even train their players. You might have seen that tablet with their coach. These all are the computer vision application, and the data analytics also. There is a multi-post tracking. Matlab, means we can track multiple objects, multiple people, multiple uh, do this in a multiple way. A sports team behavior analysis, like we want to analyze the team building, how player moves in a football in a football field, how we can even do better. Well, let's say example of the if the football is in this part of the field, and what is the best position for this, so we can train the team before it happens. uh, let's Ball tracking and trajectory data. This we see in cricket itself. They we have the system to identify the ball speed. I don't know what they use to identify the speed, but for the ball trajectory, and we for the all things we can use the ball tracking and trajectory data. Even with the help of augmented reality, we can use this as a training of the batsman or the bowler. Um, for the if you want to train the batsman with the fast paced bowler, So we can have virtual reality or augmented device wearing it, and he can even play from his home, or in a even room. The baller can throw the ball from in his room. He just have to act, and the data will analyze his speed, and the ball will deliver in a batsman groups. These are the application in the virtual reality and augmented reality part, but with the help of computer vision. Yes, the automatic highlight generation. Let's say the Hotstar. They developed the system to like when the audience cheers up, they knows that this is the main part of the content because the audience likes it. So they cut the clip and post it on their media. So this can happen. The imagination is the only limit in the computer vision, because we are now at the age of the starting of the era that we will see the boom in the computer vision applications. We are now exploring the applications of it. We have developed some algorithms, but applications is still evolving. I have given here a link that in tennis they highlight this automatic highlight generation use in tennis. And the field of agriculture also, we can also monitor the crop and weeds also. I have some seen the videos that with there they made some robot that automatically removes the weed between the rows of the plants, uh, because that use the computer vision and identify this is the weed. In this picture we can see the yellow boxes are unwanted, so, and the green box are the our plants. Flowering detection and the plant disease detection. Before disease happens, sometimes we can predict the disease. Automatic weeding, irrigation management, water flows, and all things. Farm automation. What in a transportation, vehicle classification, parking spot detection, traffic flow analysis. In a metro cities, we always face the traffic. So if we have the traffic flow analysis and the guide, even Google Map uses this to traffic flow analysis. Automated license plate detection. If our RTO can works on it, we'll have mm, more memos at our home if they use automated license plate detection. Driverless cars. This is the evolving still, and the road conditioning monitoring. And so for the geotagging from the satellite images, we can see that this road's condition is not good, so we can, or even sometimes what happens, human identifies that this road is become weak, and in 1 or 2 year we have to rebuild it. So computer vision can also do this thing before, because the pattern is the always same. Computer vision in education. Let me see the video. Uh, so this is the ProMath application someone made last year, or 1 or 2 year ago, that scans the application, the text, and identify the text. Then it applies the algorithm. So in computer vision in online teaching, let's example for the example, I made that tool that can help in online meeting or the online teaching. The problem solving like this ProMath have developed the application. The even in a virtual reality world, like let's say augmented reality, uh, when we write X, this see the it it draws the graph automatically. So you have heard the news of Google Glass or Apple Glass. So after wearing the glass, you will have this type of instant analysis. In another industries, let's say take a jewelry industry. This is the small MSME industry application. With the help of augmented reality and the computer vision, we won't have to go to the shop to buy the jewelry. Even in a spectacle, they have implemented this thing, I think. uh, yes, I would like to have interact with you. What other applications you find? Post it in a comment. Am I audible?
Yes, sir. Everyone is putting their messages in chat box. You can check it after the participants. Yeah.
If you want to analyze or track any objects with the part, should we focus for the accuracy? Yes, yes, first of all, you have to find the part, which part you want to focus on, like, for but first of all, find the part and then analyze it. Like I said, I am working on the tongue segmentation, tongue classification. So what I did was the first identify the tongue. This part is a tongue. Then I put in my model, so that that removes the other part. I would say that other background, I would make it black, and then I feed in my algorithm, so it will increase my accuracy. So data, you should focus on the data for the accuracy. Yes, the Snapchat, that's a good example. In a recent, we have seen this Instagram filter. This is with the help of the computer vision. They identify the body part, where it moves, and in a game development, we can use the Instagram and Snapchat filters. We have lots of filter and jets in a recent time. Even application like Prisma gone viral based on this only. They have made the style transferring. This image has some style, and that transfer to your photo. This is my coworker, and he had made this application, not the application, but he wrote the program and to play the game.
Round one, fight. Huh. You win. Round 2. Fight. You win.
This is the application in augmented reality.
Yeah. I'm ready to play now. Put me in the game now. I came here to prove it. I'm ready to do it. I can't be afraid now. Put me on the stage now. I'm ready to rage now. I feel like an animal stuck in a cage and I'm ready to break out. My time, my time. None of you people can tell me to stop. This time, like the last time, you better get ready to race to the top. I'm ready to do this. Show you what the truth is. I step on the field. And you people can tell me to stop. My town, my crown. We know me to stop. My town, my crown. We know.
In game development, in next generation games will be right now in we have how we raised that our parents also said that if you play the game you won't have the physical strength, but in the next world who plays the game will be the fittest, because all the games will be with help of augmented reality. You will have to do exercise with it in virtual. I'm skipping the virtual reality part because it is the beyond of scope. Let me see the comments. If so, now come to the second part of our this session. How computer vision works. I'll show you the basics, very basics. I want to go in very deep. So I'll tell or convey in a very layman language. So the first we will have to understand the image or pixel. You all guys are from computer background, so you know what is pixels and the images and the color format RGB, red, green, and yellow, blue. So if you have the, let's say, example of the grayscale image. So this is the grayscale image. For the zero we use the black, and for the white we use 255, 255, all 256 value to. So this is the example of grayscale image. And computer vision with deep learning. So what computer vision with deep learning is do to find the features or the style in the images. So let's say this image, we have the dog, and it has some specification ear of the dog, so it finds it. So these are the features. Sometimes the features can be explained in different ways also. This is mm, uh, on the right hand side you can see the embossed image. So this can also work as a features from this image. There are many features in the image, but we cannot manually do it, so we need the help of deep learning. So we I just talked about the Prisma application. Prisma application was the one example of style transfer. What style transfer does is, this is our content image on the left hand side, river and the houses, and this is the style reference is a famous picture of some artist, and we apply this style on this left hand side image, and we get the output from the combination of these two image. So in a middle part of the picture, we see that the image has a unique style we cannot identify with manually. There is some round part we can say, but another apart from that we cannot identify, but deep learning can identify and apply these styles to the content. So the style is what the image it finds the features in the image. So with the computer vision and deep learning, I'll talk, explain you few terminologies, then we will implement it. First is the you will have to understand what is kernel, convolution layer, max pooling, and flattening the image. These four terminologies are essential for the computer vision. So what are the kernels? Kernel is a 3 by 3 or the whatever size you can choose. This, but is a matrix which we with which we multiply the image. Like this image has some values here. Uh, let's say this is the kernel 140 140 0 minus 1 0. This kernel is multiplied this with this part of the image. So mm, hmm, hmm, hmm. 1 second, I will have to explain it from here. Yes, kernel moves around the image and generates another layer. This is basic matrix multiplication we do uh, in our college or the maths lectures. So let's say this is the right hand side. We have the image. We want to see the uh, horizontal part of or the vertical edges of the image. So we will apply the kernel. Say let's say -1 -1. So now you can see the only horizontal edges of from that image. If I rotate this matrix from the -1 -1 from the top line to the uh, vertical part, let me convert this -1. So now you see the vertical edges of that image. There are many custom filter I have applied, but let's say you want to emboss the image, so you will have to multiply with this type of matrix to the image. So what happens in the multiplication? Focus on this part of the image, and let's say its value is 254 54 55 and this, and so we'll multiply with this -2 with this here, then this -1 with this pixel, 0 with this pixel, and then add all the values, and it generates a 210. Then we will put it here corresponding to the part. So you see the here example of the kernel is the orange part is kernel, and then we apply this on the image. It becomes the convolution process. So this is all about convolution process. We apply the kernels and it generates another image that might have the less number of pixels or the size of the original image. See, check here, 1 2 3. We have added padding here, so we won't find it. If we have the RGB channels, 3 channels, what we do, we apply one kernel on each channel, then add all the values and create one another output. This will have only one layer. If you want a multiple layer, we will use multiple kernel, multiple processes. I have attached the link of the Wikipedia that has the identity kernel. Have you checked the identity matrix? This is the meaning of identity matrix. If you apply with the original image, it will give the original image. For the edge detection, we can use this type of kernels and sharpen it, blur. In our mobile application, we have these features that can blur the image. So what basically they do is they multiply with this. Now you can go and apply some algorithms on the image, and you can modify the images. So this is the another method. For the better understanding, I have captured multiple sources to explain you. Take a time and watch and analyze on your own. Instead of kernel, we can use the term filter. Then another term is max pool or average pool. So what we do is if we have the large pixel, or let's say in megapixel, but we don't have that much of processing power, we want to minimize it. So what we do is average pool or convolution. This type of filter we apply to minimize the images. This number is 12, 20, 12, and 8. What is the maximum number of it? It's a 20. So we use the 20 here. 30, 0, 0, 2. Maximum is 30. If we use the average of these 4 pixels, it becomes the average pool. Then comes the terminology, the flattening the image. If we have the 3 by 3 image, 3 pixel by 3 pixel. If we flatten the image, it becomes a vector of 9 pixel. Let me show you some classification. So this is the Google Colab, in which we can write the code here and implement it. So for the first, we will download the data set. I have written the code here, and this is the I have took it from the tutorials from the TensorFlow itself. So TensorFlow is the library for the machine learning. It is developed by Google, and we import it here in our for the example. These are the cells we will execute, and this it will shows our output here. Let me see. Okay, we have imported the necessary libraries here. Now I will import the data set. So from the TensorFlow itself provide the data set. So I will be downloading the C4 data set that contains 60,000 images, and with the 10 classes. And for the test training, we will be using 50,000 images, and for the testing purpose, how our model has worked, we will use the testing 10,000 images. We will bifurcate it. So I have data sort dot c4. This will load the data of all the 60,000 images in these 4 variables: train images, train labels, test images, and test labels. Let me clear the terminologies. Train images will be the images of 10 classes, say aeroplane, automobile, bird, cat, deer, dog, frog, horse, and sheep. These are all the 10 classes in this data set. And the labels is what? Labels is the answer. If we have the picture, and picture, what picture is this? This is airplane. This is automobiles. So we download is all the images and all the answers from it. So we can feed this into our machine learning algorithm, then it will learn from it. It is very easy. Computer vision for the basic one, we will be doing in 10 lines of code, and we will have the training model ready. We have downloaded the data. Let me first come to your meet, and anyone has a doubt, you can write it here. Yes, Harsh, I will come to it after this exercise. We will be discussing. But for the this PPT part, if anyone has a doubt on the terminology, on you can ask in uh, comment. I'm waiting for 10 to 15 seconds.
I request the audience, if anyone wants to ask any question regarding the PPT verbally, they can also raise their hand.
Yes, because this is I cannot see all you, I cannot see your expression, so you have to write if you have some doubts. So okay, let's move. I don't.
Sir, I guess everyone has understood
Yes.
everything, so
Okay.
we can just move further.
So I'm just showing the classification of the. So I have downloaded the data set here. Let me run this cell so that this bifurcates the data sets in here. It has bifurcated the data set in 4 parts, and a training image and test image. Training has 50,000 image, and test image has 10,000 images, and all the answers are train labels and the test labels. So the values are from the 0 to 255. For the machine learning, we use the we normalize the data between 0 to 1. Um, I'm not going into detail why do we do this, but in future, if you want to learn, I will explain. But we will be dividing all the pixel value by 255. Just to verify the data, we have the class names here. I have made a dictionary here, a list of the class names. And let's say first is aeroplane. Let's say what is the fourth? Fourth is deer. And let's say example of train image. Data of the. So this is the array of first image. I have wrote the year 0. If we want the fifth image, I will write here 4, and this will execute and bring the fourth image and the pixel values of the fourth image. But we cannot see the values in the picture, so we want to see the what are the real images look like. So we will be using pyplot library. I have imported here matplotlib.pyplot, and in a short form we have imported as a plt. So what this library will do is this will show image show. We are using this function, and we want to see the what is the first image or a second image. So I write here 1, then I execute it. So this is the showing us this image is of the truck. There is one category here, truck. Okay. If you want to see multiple images, we can do this in a matplotlib library that can show us random images from the our data set. This frog truck. This is 30 by 30 images, so this is not in a megapixel value. For our test run, we have low quality images, but you can see this is horse. So let's create our convolution model first. This these are the 5 lines of the model. and that's it. We are done with the model, creating the model. So first is like a sequential model. What is the sequence? Let's come to the, yes, convolution. This is the graph of the convolution process or classification of the image. For what we first do is apply the kernel here. 5 by 5 kernel is apply on the input of the 20 by 28 by 28 images. Then if we apply 5 by 5 kernel, it becomes the 24 by 24. But we don't want only one channel, so we do it like n1. Let's say we want it to 50 times we apply the kernel, so we will have the 50. It's the length of this second channel. There is channels, n1 channels is represented with the help of the length of the second part. If we apply the max pooling, where max pool we have discussed with maximum of the values, it becomes even small image. Then we apply the convolution process. Convolution process is we have discussed here. This is the convolution process. We apply the convolution process, and then again max pool here. So convolution max pool, convolution max pool, and then we create a fully converted connected image. For to connect a fully connected image, we flatten the images, convert into the vector, not the 4 by 4 or 2 by 2 images. We want a vector, so we flatten it and then feed into our neural network. Neural network will analyze it and give us the probability for the each classes. For the zero, red dot is the zero, it will have the probability of the first class. Whatever the maximum whatever the class that gets the maximum probability, we will take it as a output or the prediction. Okay, so our model here has a sequence in it. We have a sequence here, first, second, third, fourth one. So in the TensorFlow, we use the sequence model. We will add the layers. First layer is the convolution layer. Second is max pooling, then convolution, then max pool, and convolution. These are the 5 layers we are adding in our model. You can add multiple layers and experiment it with it and to increase your accuracy. So in this example, in this image, convolution max pool, and fully connected, that flattened image. And in here written code, convolution max pool, convolution and max pool. And this is the size of kernel, 32 3 by 3. We are using 3 by 3 kernel, but 32 times. Then we will use 64 times, then 64. This is the basic language with Python you can use. If I run this and create a convolution base, so our model is created. I have run this cell and we will see the model summary here. Yes, model.summary will give us the model summary. Convolution max pool, 30, the image shape is input shape is 30 by 30. Then we have applied max pool, it becomes 15 by 15, then 13 by 13. This. Okay, and then at last we add the flatten, but it has a 64 filters, so we want we will dense it to the 10. So what if we have the 60? Yeah, this green dot is 64. What if we have the 64 probabilities? We don't want it. So we add one another layer, and last layer will be our classes, 10 classes. So we will use the 10 filters. So we use the 10 dense, and then we again create the model summary. This is the summary. convolution, max, convolution, max, convolution, and then flatten, dense to 64, dense to 10 classes. We want 10 probabilities only. Now we will compile the model, and I have wrote here model.fit. What will model.fit will do? It will take the train images, our data set, train labels, our answers, and the 10 epochs means it will revise all the data set 10 times. The validation data is it will we have used the test data. First time it will learn from the all data set, then it will come to the validation data, test images. It will see the what is the accuracy, then it goes back and again check the train images. So for the first round it has got a 53% accuracy. Now it is learning again all the 60,000 50,000 images. It has got 61 images, 61% accuracy. Our model is training itself with the simple code model.fit, and we have given this input of the train images, train labels, and the test images and test labels for the validation accuracy. So we can see the accuracy increases one by one epochs. Epoch is revision. You can revision of the data set, all the data set. We can define the epochs. How many epochs do we want? If we want it to learn 100 times, it will learn, but it will overfit. It won't generalize in the real world. So finally, I think yes, the model has been completed, and it has the accuracy around the 71% on validation data. We can evaluate with the simple code, which is still running. Let it run. We can evaluate also model.evaluate. It will give us the output of accuracy 71%. And I have plotted the accuracy chart, but we don't need to see right now. But we have finished our model training part. Model.accuracy, it gives our accuracy. We can plot even if we want the process. If we want to plot this process, 53%, 61, 62, 70. I have plotted it here. And test accuracy. So this was the classification of the images. It has learned it is rightly predictive of the 71%. For the basic to start, 70%, 71% is very good with a few lines of code, few data set, and few epochs. But you can modify this data set, and you can work on it to even make it more efficient. So this was yes. So let me show you the convolution visualizer. Can we go 5 or 10 minutes beyond the time limit?
Yes, sir. Sure. It will do.
Yes, I'm showing the convolution visualizer. Let's say input image. This is input image. Weight is our kernel, and this is output. Let's make it small. 5 kernel size is 2 by 2, and padding is 1. Padding is like black part in the image. Let's make it 0. If the kernel input size is 5 by 5, the image is 5 by 5, and we use the kernel of 2 by 2, our output of the image will be 4 by 4. I'll send this PPT. You can explore these links. This is very good example of so the at the bottom we will input our text. Let's say the example 5, and it has created. Yeah, this is the first layer, second layer, third, fourth, fifth layer. How computer sees the images after one by one layer. Then the flatten. At last, we can see the flatten, and the output we can see the small dot near the 5. It's 0. It is outputting it gives a 2 output, 8 and the 0. 8 because I have not written clearly. Now it shows the 0. If I do it here, it's confusing with the 8 and 9. Based on the accuracy of the model, uh, how you train, it will depend on it. I have shown you almost all things. Okay. Now the Q&A part. Yes,
Yeah.
now you can answer the questions. First, okay,
Sir, there are
let me
few
go through the
questions.
comments. Yes, let me go through
Yeah.
the comments. What is the best way to get started with the computer vision as a beginner? You have begun your journey in the computer vision. You have made the one project with the help accuracy of 70%. You can learn from the even Google TensorFlow tutorial. They have. Let me show you the example. Just type it here. TensorFlow. TensorFlow is the Google library tutorials. So for the beginners, they have all the things noted down here. You just go to any lesson. You will have the code here. If you want to explore it, run in Google Colab. Yes, it is your cells, and you can run it here. Uh, what is where can I learn media pipe? So in computer vision, there is no like in colleges, or we have incorporated in our syllabus, or many even foreign universities haven't yet incorporated in this. Some of the universities, good universities, have done in the research part, but like you are doing this in the research cell. So but if you want to learn these new things, you learn one thing to how to read the documentation. If you want to learn the media pipe, go to the media pipe website and check out their documentation. They explain it how to use it. So explore their website. This is the first source. Then second source is all we know that YouTube. Go to the YouTube and search for the videos. You will find lots of videos. You don't need to any extra paid tutor. If you want a certificate, you go for the paid certificates. But if you want to learn in a free, YouTube is a great source. Does resizing affect the image resolution? Yes, we decrease the resolution by resizing it. Normally, we divide the data 70% as a training and 30% to test. And how you decide that 2050? So for the even 10,000 test images is very large. If you want a small number 5,000 images, for the test is very good. But for the validation data is what it computer vision or the algorithm uses during the training part. So do it 80-20 or the 70-30. There is no hard and fast rule. You can experiment with it. But for the separate test of data, you can have, for if you are dealing with a large number of data, so you can divide it in 90% in a training part, 5% in a validation, and 5% to the test. You can divide it if you have very large data. Based on data, you can adjust it. Present is good, sir. Thank you. Which framework algorithm did you use in your real time writing with your for the real time writing? I made my own module first for the hand tracking, but it was not very good for the real time part. It was doing in a recorded, and it took the time to process. But then the media pipe, the last year got released, and I used the media pipe. Then with the help of hand tracking media pipe, and then with the I created a canvas, track the fingers, and then merge it. For the dataset having the images of a smaller size, is it advisable to use the padding to increase the size of the images, or should we alter the first few layers in the model, or accept? If you are using the padding, that is good. It will have the information centered, and it because there's some with at the starting or the corner part of kernel that will forget, or the corners of the images. But most of the images what we see is most data is focused or center at the center part of the image. If you feel that if you can have the, like, you can ignore the corner part, so there is no need of padding. But if you think this is a corner part is very essential, or the image is not very large, so use the padding. For dataset having the images of source. Okay, we have done. Any other questions? You can even ask with camera on and mic. Atharva will give permission.
Sir, there is one more question about skin disease detection. Can you just scroll
Sure.
down? Get it. Yeah.
Sir, I'm working on a skin disease detection. So can I use Google Images as a dataset? If you find the like medical dataset, it will be very good. If you are using Google, if you don't have the dataset, because right now what happens is data privacy is very concerned, and so you will have some difficulty on the data skin dataset. But Google Images will deteriorate some model quality, but if it works, if it will work in a real world application. For the my tongue analysis part, I have used I have the data set of research data set, and medically collected the data set. But at some point I feel that I need more data sets. So what I did was I collected and generated data with the help of Google Images. But Google Images has a very you, like small images. I use the Yandex search engine.
Sir, I guess we are done with the questions.
Okay.
Yeah. Sir, now I would also like Mr. Kulin Patel is also a mentor for he mentors for the projects and internships. So and he also offered us to like give mentorship to our students on computer vision and deep learning. So, sir, can you tell more about your what you are gonna offer and
Sure.
all the details
So
here, sir?
if you want to learn computer vision or the data science, or specifically, I will focus on the computer vision. If you want to start your journey, I'll be helping you, and you can make your group, or we can have a discussion. You can organize the talk. I will be answering your questions. Well, I'll be giving you the path what you should learn from. First, learn this. I'll giving you the free resources, uh, and you by your own ability you can learn. But what you need is the path, because in data in Google you will find lots of advices. So what specifically from your background what you need, I can give you and assure you the good path.
Okay, so sir, thank you, sir, for such an enlightening and wonderful presentation on the right way to introduce application of machine learning and computer vision. I think being part of a series is pleasure to everyone. So I would like our audience to turn their camera on.
Yes, let's have a screenshot.
Yeah, let's have a screenshot.
Turn on the cameras.
Yeah, please.
We don't have permission to turn on the camera.
Uh,
Give permission.
yeah, Shubham, can you please give the permission? Great. Yeah, great. Thank you so much. I think being part of a series is pleasure. On behalf of Shah and Anchor Kachi Engineering College, I have a small token of appreciation for our speaker. So please accept it with our sincere thanks.
Thank you.
Thank you so much, sir. Now, as I
Thank
told
you.
you, yeah, thank you so much, sir.
I wish you
Uh,
all the very best and good luck for the future. And don't be disharm or the like if you don't get the internship or the job. But if you are doing the good and you are making your own projects, it counts as a work. You have done the work, because the company sees that you are not sitting at home but you are doing the work. So focus on learning, you will get the job, not from the college. If not, but you from the industry, there is lots of demand in computer vision specifically. Even I am looking for the interns for the this, but I am not finding the good candidate. So start preparing. What happens in the future, we meet in uh, next 6 months or 1 year, we can have some professional relations too.
sure, sir, sure, sir. Now, as I said at the start of this webinar, that we have some surprise announcement for you all. So now we have one more surprise announcement. A SAKEC research cell, in collaboration with numerous colleges affiliated with University of Mumbai, is looking to recruit student interns to build an engineering science virtual lab. You will get the opportunity to build an interactive physics simulation engine using first principles, learn and use state-of-the-art web technologies, collaborate with other highly skilled and like-minded peers from numerous colleges in Mumbai, and be mentored by senior and distinguished faculty from top colleges scattered across Mumbai. For more details, just scan this QR code on the screen or visit SAKEC Research Cell's website. Thank you each and everyone for Thank you each and every one of you for your presence here today, and thanks for being such a lovely audience. Participants, please fill the feedback form. The link is provided in the chat box. Please don't forget to upload your selfie. Thank you everyone. Stay safe and sound. And also the internship link will be provided in the chat box itself. Thank you everyone.